Welcome everybody. It's Ramchandra again from CIVIL-MECH-MATHS-CONCEPTS. In this video, I have taken up a T-beam for calculating the moment of inertia with respect to center of gravity. This is the 8th lecture in structural analysis topic. It is the lecture number SA8 for GATE, SSC JE, FE and PE exams and UPSC ESE. For these examinations, this lecture will be useful, and in the previous 7 lectures on structural analysis, I had described about members, forces, types of structures, supports, and then resolution of the forces, numericals on forces, and also beam theory. M by I is equal to sigma by y is equal to E by R, where sigma is the applied stresses which can be found out from the formula M y by I. Sigma is equal to M y by I, where I is the critical component. This is moment of inertia, or it is called as the second moment of area. This is what is going to decide about the applied stresses, and once the applied stresses are found out in the beam, then it can be compared with the allowable stresses, either to reject the design or to accept the design with a pre-approved factor of safety as per the different types of codes of design. Now, I have already discussed about sine wave form beam in the shape of sine wave, and second I have discussed about the semicircle, sine wave, semicircle, and in the last class I have discussed about rectangular shape. Using calculus, we have found out the moment of inertia. First we have found out the area, then from there we went to find out the first moment of area, and from there by the ratio of first moment of area to the area we found out the center of gravity, either on with respect to x-axis or with respect to y-axis. Then we went on to find out the second moment of area with respect to x-axis and then with respect to center of gravity. These are the 5 calculations we have done. For rectangular beam, a beam in semicircular form and a beam in sine wave form of one cycle. Now, let's go for a T-beam. T-beam, I-beam, T-beam, I-beam, C-channel beam, hollow rectangular beams, circular beams, hollow circular beams, These are the different types of beams we regularly use in our day-to-day engineering practice. And let us try to find out a typical structure of a T-beam. T-beam has two rectangles. It's not a single rectangle. It's not a uniform symmetrical. It's neither uniform with x-axis nor uniform with the y-axis. We can say to some extent it is uniform with y-axis. The given example, because on both the sides flange width is same. Whereas flange width may be different. The top portion is called as the flange and the vertical portion is called as the web. If flange width on both sides is not equal, then we can't say it is symmetrical about y-axis also. We have taken a T-beam where it is not symmetrical about x-axis but symmetrical about y-axis. Now, the nomenclatures I will define one by one. Flange is the top portion of the beam, or flange can be either at the top or at the bottom. T-beam can be either in this fashion, inverted T-beam, or T-beam can be like this. This portion is flange and this portion is flange and this portion is web. This is a straight T-beam, it is an inverted T-beam, inverted. Now, we have taken a straight T-beam with a flange width of 10 mm and flange breadth of 100 mm. And a web width of 8 mm and a web height of 100 mm. This is what is the T-beam we have taken. What we have to do is find a area of the given T-beam. Second part, first moment of the area, first moment of area of T-beam. C, center of gravity of T-beam. These are all with respect to x-axis. Axis is at the end of the beam. This is the x-axis. At the bottom of the beam is x-axis. Now, next is Ixx of T-beam, that is moment of inertia or second moment of inertia of T-beam with respect to x-axis. Next, fifth one is ICG. That means moment of inertia or second moment of area with respect to center of gravity of T-beam. Now, we start the solution. Please follow the same procedure in all the questions which are being asked in the examination, so that there will not be any error. We will take up another beam in the next lecture. In this lecture, I will explain fully about the T-beam. T-beam has got two rectangles One is flange, second is web. At this particular point of time, forget about the values. This is 100, this is 10, this is 8, this is 100. No. Flange will have a thickness that is called as TF, and flange will have a breadth BF. For web will have a height, web will have a thickness. In rectangular, what I have told you, when it is with respect to x-axis, some rectangle is there. When some rectangle is there like this is y-axis, this is B, this is H, means what is the area? Area is equal to B into H. Please recollect from my previous lecture. Please see my previous lecture for rectangular beams. That is SA 7 from CIVIL-MECH-MATHS-CONCEPTS channel. GATE Civil Engineering by IIT Alumni, Moment of Inertia. SSC JE Civil Engineering by IIT Alumni, Moment of Inertia. In structural analysis part, lecture number 7, I have explained these values. Area is equal to BH. First moment of area, what is that value? BH square by 2. What is the center of gravity with respect to x-axis? YC is equal to Y bar is equal to H by 2. For this particular shape I am talking about. And what about the IXX? This, for example, here, let me extend this up to this. IXX is equal to BH cube by, what is the IXX value? BH cube by 3. ICG is equal to BH cube by 12. These are the values which we have calculated from basics of calculus and from definitions, and these values I told you to remember. These are the values. Now let us divide the given T-beam into two rectangles. Everything we are calculating with respect to x-axis. Please remember that. Now, area. Let us call the flange part, that is, this is the flange part. Let us divide it separately. Let us not club both. This is the flange part. and this is the x-axis, because we are doing all calculations with respect to x-axis, and because this is the center line, this is 10 mm, that is flange thickness. Here we are not considering web, please try to understand. I am simplifying the calculations so that this is breadth of the flange, thickness of the flange is 10 mm, breadth of the flange is 100 mm, that is what is given. This is an example taken by me and not copied from any textbook. Now, with respect to x-axis, what is this area? Either with respect to x-axis or y-axis, the area is same. Area is equal to BH. B is the breadth. What is the breadth? That is 100. What is the height? That is thickness of flange. That is 10. That means 1000 square mm. This is the area. Then we have to find out the first moment of area. One value is come. This is for part of flange. Let us say it is for flange. Next is first moment of area. First moment of area is integral y dA. Integral y dA. For flange, it will be, we are only considering flange now, we are not considered web. What is this height? From x-axis, it is 100 mm. It is given in the problem. Y ranges from, this is 110 mm. Do you agree? Up to this it is 100 mm, this is 110 mm. This is from x-axis distance. Now, first moment of area is equal to y dA. This can be written as first area of the flange is equal to 1000, area of the flange first moment, let us say, that is equal to, I can rather, it will be easy to write like this instead of this. First moment of area, not mi, we can say first moment of area flange. First moment of area of the flange is equal to integral, double integral y dy dx. What is the dx value? Here y range is 100 to, y varies from 100 to 110 mm. X varies from, let us say this is the x-axis, this is the y-axis, this is only center line, not axis. This is y-axis, This is the origin. X varies from 0 to this is 100. 0. X varies from 0 to 100. Y varies from 100 to 110. This value will be integral. Let us not put the limits now. Y dy will be y square by 2. Now we will put the limits. Y limit is 100 to 110 dx. What is the value? X varies from 0 to 100. Do you agree with this? Please try to understand. If you want any clarification, please refer to my earlier 3 lectures on moment of inertia. It is very simple. Then integral 0 to 100 y square by 2 means 110 square by 2 minus 100 square by 2 into dx. That is equal to 0 to 100. 110 square is 110 square by 2 is how much? Let us see. 110 divided by 2, 6050 minus this is 100 square, it is not 110, this is 100 square (5000) dx. That is equal to 0 to 100. 6050 minus 5000 is 1050 dx. 1050 is constant. Integral 0 to 100 dx. Integral 1 dx is nothing but x. That is equal to 1050 into x within limits 0 to 100. That is equal to 1050 into 100. That is equal to 105,000 mm square. This is the first moment of area for flange. Now, first moment of area for web. We have to find out. First moment of area for web. First moment of area. Integral double integral y dy dx. What is the web with respect to x-axis? Web looks like this. This is the x-axis. This is the y-axis. And this thickness is how much? 8 mm. The height is how much? 100 mm. Now, what is first moment of area? First moment of area for web is equal to double integral y dy dx, that is equal to integral y square by 2 into dx. This y square by 2, y is varying from 0 to 100. Here what is happening? Y is going from 0 to 100. X is going from 0 to 8. Now, this will be equal to integral x is from 0 to 8, y square 0 to 100. That means 100 square minus 0 square by 2 dx. That is equal to integral 0 to 8. 100 square by 2 is 5000. 100 square is 10,000. 10,000 by 2 is 5000. 0 by 2 is 0 dx. 5000 is a constant, we will take it out. Integral 0 to 8 dx. Integral of 1 dx is x. Then that will be 5000 into x varying from 0 to 8. When the lower value is 0, that value will be 0. Then when upper value is 8, we will put 8 as the value. That will be in the bracket. 5000 into 8. That is equal to 40,000. Cubic mm. Previously it was 105,000 cubic mm. It is not square because y dy. It is 40,000 cubic mm. Therefore, the total first moment of area of T beam, given T beam is equal to first moment of area of web plus first moment of area of flange. That is equal to 105,000 plus 40,000. That is equal to 145,000 cubic mm. Now, this is equal to double integral y dy dx. And area is double integral dy dx is equal to area. How much we have got? Total area we have calculated just now. Total area is flange area is 100 into 10,000 and web area is equal to, what is the web? 8 into 100. That is equal to 800 square meter. That means total area is equal to 1000 plus 800, that is equal to 1800 square mm. Therefore, center of gravity y coordinate is equal to yc is equal to y bar is equal to integral double integral y dy dx divided by double integral dy dx, that is equal to 145,000 divided by 1,800. You please calculate that. 145,000 divided by 1800, that is equal to 80.56 mm. Center of gravity y bar is equal to yc is equal to 80.56 mm from bottom x-axis. Till now we have found the total area of the T-beam and the first moment of area of the total T-beam and the center of gravity of the T-beam. Now let us draw the T-beam with values. This is the T-beam. This is 10 mm. This is 100 mm. And it has a web. It is 8 mm. This is 100 mm. And there is one center of gravity at a height of, this height is 110 mm and at a height of 80.56. Here approximately, here at a height of, it is not to scale, at a height of 80.56 mm, center of gravity is there. This is equal to yc is equal to y bar. Now, this is the center of gravity of the total T-beam. Now we have to calculate Ixx and I center of gravity of the total beam. Now, this beam will treat as 1, this beam as 2, flange as 1 and web as 2. And the center of gravity of the flange CF is, when we consider only flange, this is 5 mm, and when we consider this distance to this distance, how it will be, how much? 5 plus, this is 80.56 means how much it will be? 100 minus This is 100. Please try to understand the concept. 100 minus 80.56, that is equal to 19.44 mm. Then distance from IXX and ICG we have to calculate. Now, distance of center of gravity of flange to center of gravity of total T-beam is equal to 19.44 CF plus 100 minus CG, 100 minus YC, that is equal to 19.5, sorry, 1 minute, that is equal to CF is 5 mm plus 100 minus 80.56, that is equal to 24.44 mm. This is the distance between the center of gravity of the flange alone and the total center of gravity of the total T-beam. This we will call it as D1. The distance between this and center of gravity, let us call it as D1 for the area 1. Now, when you know the center of gravity of a beam, then the ICG of flange alone will be what is the height of the flange? TF. What is the breadth of the flange? This is BF, this is TF. BF into TF cube divided by 12. You see the derivation for this formula in my previous lecture. BH cube by 12 about the center of gravity. ICG of flange alone will be BF into TF cube by 12. What is the BF value? That is 10, 100 BF. TF is 10 cube divided by 12. 100 into 10 cube divided by 12. 833.33 mm to the power of 4. That is ICG of flange alone. ICG of flange with respect to CG of T-beam. Ultimately, with respect to CG of the T-beam, we have to find out. ICG of flange with respect to CG of T-beam from the parallel axis theorem, which I have explained in my previous classes, previous lectures, please refer to them. That will be ICG flange alone plus A into area of flange into d1 square. d1 is 24.44. The distance between the center of gravity of the flange. We are only considering flange here. We are not considering web. Forget about the web. Only talk about the flange. That is equal to d1. That is distance between the center of gravity of the flange and the T-beam. Because we wanted to find out the center of gravity with respect to T-beam center of moment of inertia or second moment of area with respect to center of gravity of the total T-beam. We have to find out the distance between the center of gravity of the flange and the center of gravity of the total T-beam. This will be $8,333.33 plus what is the area of the flange? 100 into 10, that is 1000, into what is d1? 24.44 whole square. That is equal to, please try to understand the concept very clearly. 8,333.33 plus 1000 into 24.44 605 647 605 647 mm to the power of 4. That is for flange. Here we are directly going for calculation with respect to ICG, because ICG is the most important. Others are not important. ICG. Now, ICG of the flange. Now, we will go for ICG of web. Here, we will write ICG of web. ICG of web is equal to, with respect to ICG of web with respect to T-beam center of gravity is equal to ICG of web self plus A into A2 into D2 square. This is D1. Now, from here to, what is the center of gravity of web? Center of gravity of web will be here. This is center of gravity of web. This is at a distance of 50 mm because it is at a HW by 2. This is equal to HW. Center of gravity of web y coordinate is equal to YC web, that is equal to y bar web is equal to HW by 2, that is equal to 100 by 2, that is 50 mm. For clarification, refer to my previous lectures. When a rectangle is there, the self center of gravity will be at a height of h by 2, that is 100 by 2, 50 mm. The distance between this center of gravity, that is y of web, yc of web or y bar of web, and the total center of gravity of the T-beam. Center of gravity of T-beam y coordinate is, every calculations we are doing with respect to x-axis, please remember, y coordinate is equal to y bar T-beam is equal to 80.56 mm as we have calculated. Therefore, D2, that is equal to distance between center of gravity of T beam and center of gravity of web is equal to y bar T beam minus y bar web. That implies D2 is equal to y bar T beam is 80.56 minus y bar web is 50, that is equal to 30.56 mm. Here I will show in blue line, this is D1 and this will be D2. Rather, I will call this as D2 from here to here. This will be D2. Here this will be, I will put it in the green ink or this ink, green ink. This is green ink is D1 and blue ink is D2. Now, from parallel axis theorem, with respect to CG of T beam, if we have to find out ICG of web with respect to T beam CG is equal to ICG of web plus area of web into D2 square, because that is the distance between the center of gravity of the web and center of gravity of the T beam. Ultimately we have to find out with respect to T beam CG. That is equal to, what is the ICG of web? ICG of flange we have found out. ICG of web we have to find out. ICG of web is nothing but BH cube by 12. What is the BH cube by 12? This is thickness of web into height of web whole cube by 12 plus area of web is 100 into 8 into, what is D2? D2 is 30.56 whole square. That is equal to, what is TW? Thickness of the web is 8, height of the web is 100, 8 into 100 cube by 12 plus 100 into 8 into 30.56 whole square. This value, when we do the calculation, this will be equal to 8 into 100 this will be 666. This value will be 100 into 8 into 747,131. This total will be 666,667 plus 747,131, 1413798. Now we have to find out the total ICG of the T beam. ICG of T beam, because it is having two rectangles, this is ICG of flange with respect to CG of T-beam plus ICG of web with respect to center of gravity of T-beam. Sum of these two will be total. This implies this is equal to what is ICG of flange with respect to CG of T-beam? 605647. 605647 plus 1413798. 1413798. That is equal to 2019,445 mm to the power of 4. Therefore, the final values are important answers. Area is equal to 1800 square meter. Center of gravity, that is equal to YC is equal to, for the total T-beam I am talking about, 80.56 mm from bottom x-axis, and moment of inertia or second moment of area or ICG of T-beam. Total T-beam is 2019,445. mm to the power of 4. Even though the values are immaterial here, the procedure has to be understood well, and the procedure is if a combination of different areas are given, different shapes of areas are given, we have to consider individually the area separately and find out the center of gravity of that area, area 1, area 2 or area 3. Then you have to find out the first moment of area for each of the areas given for A1, A2, A3. Then we have to find out the center of gravity of the combined area. Once we get the center of centroid of the combined area, the y coordinate, then put the x-axis in the bottom, then find out the second moment of area for all the areas, combined area, by using the parallel axis theorem with respect to the center of gravity of the combined area. The distances between the center of gravity of the individual areas and the center of gravity of the combined area to be known, D1, D2, D3. Then we have to find out the center of gravity of the individual areas plus A1 into D1 square plus center of gravity of the ICG of the second area plus A2 D2 square, ICG of the third area plus A3 D3 square, and go on. That means ultimately ICG total is equal to, please make a note of it, ICG total is equal to ICG 1 plus A1 D1 square plus ICG2 plus A2 D2 square plus ICG3 plus A3 D3 square plus go on. This is the important formula when more than one area is clubbed to each other. This type of questions, like where are the more than one area are clubbed together? One, in T-beams. Second, I-beams. Third, channel beams, C-channel beams, etc. That means T-beam is this shape, I-beam is this shape. I means the flanges, both the flanges need not be same, they can be different. C-channel is this way. These are various number of areas, that means shapes are attached together. This is A1, this is one area, this is second area. Here first area, second area, third area. Here area 1, area 2, area 3. So that this way we can find the combined moment of inertia about center of gravity. The moment of inertia about center of gravity is very, very important in beam designs, because through center of gravity of the beam the neutral axis passes. That is the fundamental thing for which we have to find out the center of gravity. And moment of inertia will be found out for the reason of finding the applied stresses. Center of gravity to be found out for finding the neutral axis position, and to find out the applied stresses we will know from the moment of inertia or second moment of area. When we both know, then the tensile portion or compressive portion of the beam and the tensile stresses and compressive stresses on the beam, applied tensile strains, compressive strains can be found out. From them the code values, by applying the suitable factor of safety, we will compare these values with the code values. With them either we reject the beam or we accept the beam. That is the ultimate aim. Reject or accept the beam profile by finding stresses sigma and strains epsilon, compressive or tensile as explained, with the help of MI, moment of inertia, and center of gravity values of the given profile of the beam. I explained for a T-beam, that is with respect to x-axis at the bottom. Now you calculate with respect to y-axis as a homework. In the next class I will be taking up the I-beam with an example. If you have any queries, please contact me at the handle CIVIL@CIVIL-MECH-MATHS. Channel is CIVIL-MECH-MATHS concepts. It's Ramchandra again. Wish you best of luck. And these lectures are very, very important. They are useful for SSC, JE, GATE, UPSC and engineering services examinations. In addition to that, these can be utilized for FE and PE exams also. Best of luck to everybody. It's Ramchandra from CIVIL-MECH-MATHS channel. Please view, review and comment for improvement, and also subscribe to my channel for regular update. Thank you for listening to me. Best of luck.